electronic signatures across Europe. Here in DigiDigit, and together in cooperation with DigiConnect, we are operating the CEF eSignature program building block, and we would like to assist you as much as possible on providing your own signing services, your own signing solutions to other private entities or to the member states, to the civil administration of the member states. And today, in this webinar, we're going to provide you some insight about the DSS and this open source library that we develop and maintain here in the European Commission. And we have some of our top experts in order to assist you and provide you some tips and tricks on how to get started. And we strongly encourage you to reuse the DSS library because this is a reference implementation of the latest ETSI standards and the eIDAS regulation. So you can be reassured that whatever service you provide is properly aligned to the legal framework and to the latest standards. So because it's a technical session, I don't want to take more time from this webinar and talk about these things, but nevertheless, I'm going to be available during the webinar to answer your questions. And that's why I would like now to pass the floor back to Luis in order to continue the coordination of this webinar. Thank you very much for being here, and I'm wishing a very good webinar to everybody.
Great, thanks, Tolis. So, okay, to start a webinar, the first section that we're going to see is about CEF. So, diving a bit into it, we're going to start talking a bit about what the eIDAS regulation is. So, the eIDAS regulation establishes the rules for the use of trust services in Europe. So, it establishes the framework for the use of these trust services in Europe in order to achieve the digital single market. So, one of the elements that this legal framework describes is electronic signatures. And the electronic signatures described in the framework of the eIDAS have certain characteristics. So they're equal to handwritten signatures, which is, from the legal point of view, it's very interesting toward the use of services based on electronic signatures. They are accepted in all member states. One of the main values of this eIDAS framework is that it's cross-border within Europe. So meaning every member state in Europe needs to admit an electronic signature that complies with the characteristics defined by this framework. They are admissible in court. This is linked to the fact that they are equal to handwritten signature. So they are a legal equivalent to handwritten signatures, and they are highly secure because there's encryption technology used to verify the integrity of these electronic signatures. So regarding the Connecting Europe Facility program, CEF, CEF is a program that it appears in order to foster interconnection between member states, so to foster interoperability in Europe. So what CEF does, it's promoting the adoption of common standards by providing technical supports to administration, businesses, organizations, citizens in general, so a wide variety of stakeholders. Then they help them develop secure interoperable digital services. So you can see services not just based on e-signatures, but services based on electronic identities, data brokers. You have a wide variety of services supported by this program. And it also provides fund to projects that can contribute to a more connected Europe. So meaning if there are projects that are interested towards achieving this objective of the interoperability in Europe, they fund these projects too. So the support this program offers, it comes in the form of building blocks. So building blocks are reusable pieces of software, tools, etc., that allow the creation of these services in order to improve the interoperability in Europe. So within the context of the CEF program, one of the building blocks, as we defined before, that it owns, let's say, or it developed is eSignature. eSignature is the CEF building block that provides the electronic signature capability, let's say. And it consists of a set of standards, tools, and services that allow not just the creation, but also the verification of electronic signatures and seals. And it's important to remark that all the signatures and seals produced with this building block are compliant with eIDAS, with the previously defined framework for interoperability in Europe. So the uses of eSignature are basically three, which is the first one would be building your signing solution based on DSS, which we're going to talk more afterwards. But basically, the idea is that if you use DSS for building your solution, you ensure out-of-the-box compliance with the eIDAS. Okay. Then you have the ability to test the interoperability of the solution. Meaning, if you decide instead of using DSS as the basis of your solution, you decide to go for your own development or to buy a commercial solution, you can use this conformance checker to ensure that this solution is aligned with eIDAS. And finally, another thing that it does, it helps you get your trust certificates from a qualified trust service provider in Europe with a tool that's called a trusted list browser, which basically it allows you to browse through all these qualified trust service providers in Europe for you to be able to choose your certificates. So basically, it just makes your life easier to make it simple. And what's the current status of eSignature at the moment? So we have the TLSO community, which is conformed by 30 different countries. TLSO are the trust list service operators. So the operators of these trust services established in Europe. And you can see in green all the countries in which TLSOs are a member of our community. We are, well, there's currently 197 qualified trust service providers active in the EU that you can find through our trusted list browser. We have 58 generic projects that have been awarded to eSignature. And then the DSS libraries have already been downloaded, and this is DSS is the main topic of our webinar today. They've been downloaded nearly 32,000 times. There's more than 34,000 conformance checks that have been performed with the ETSI conformance checker, and there are currently 63 initiatives that reuse eSignature. So as a success story, we can see, for example, it's eSignature being used to sign an agreement with the World Bank. So this was the first international document signed with a qualified electronic signature by the European Commission. So it's important to see that this technology is not just let's say in a legal framework, but that it's actually being used. It's useful. It's legally compliant. It's used by an institution with so high requirements as the European Commission. So it's something that's currently having a lot of traction, is being adopted, and it's growing. And then we step into what is DSS. Okay, DSS, which is again the basis of the framework today, is an open source library. So it's a digital signature framework. It provides you a digital signature framework focused on the creation, augmentation, validation of interoperable signatures. It provides multiple ancillary features depending on terms of creation, PADES, ADES, etc. So the ETSI formats, supports the standards by the signature formats and backing methods and the validation for those signatures. It's written in Java, which guarantees portability, supporting Java version 1.8 and above. Validating relies on member states' trusted lists. These trusted lists that we showed you before in the map that were actually running or being managed in a wide variety of countries in Europe. And it is finally a flexible library that can be integrated in different topologies. It can be integrated in a standalone application, in a server-based application, combinations of both. So this is interesting because one interesting features of DSS is the fact that you can not just use the whole module, so the whole library. So but module by module, and it allows you to adapt it to different configurations. So it's a flexible library. So yeah, this is a bit contextual slide, so we can jump it and go straight to DSS through the years. So seeing what the latest developments have been. So we're not going to go one by one, but basically the objective of this slide, it's showcase that there's a lot of work being done on DSS, that it's been growing, and that the more that it runs, the more developments there are in it. So in recent years, there's been each time more and more work on the library because it's actually gaining adoption and being used. So it's interesting from the point of view of this thing. As I was saying before, it's being used as one of the main purposes of a tool once developed finally. And this regarding the next works are going to be happening. The next release of DSS 5.8 is in Q1 2021. And basically on the release notes of this latest DSS release, we can see that it's going to include the implementation of the new JDIS standard. It's going to include the detection of shadow attacks, and it allows the creation of counter signatures, supports the signature polystore, and Java 15. So these are the main characteristics of this new release of DSS. It's going to take place very soon in Q1 2021. And finally, we'll say why using DSS. Because, well, in the first place, as we said before, it ensures compliance with the eIDAS and with the ETSI standards. So any tool that you develop, any signing tool that you develop based on this library is going to be out of the box compliant with eIDAS and its standards. It makes it easier for you to deal with the signatures. So with all the technical side, it saves you time, saves you complexity. It's an open source library and it's free of charge. So it doesn't add the cost to the development of your solutions. It saves you time for free, which is interesting. And finally, because it provides funding for projects in the member states. So these are the main advantages of the use of DSS. And without any more delay, I'm going to leave you with Mr. Olivier Barret, which is going to conduct the rest of the presentation. So please, Olivier, if you're so kind.
Yes, thank you, Luis. Thank you very much for this introduction. Good afternoon, everyone. Olivier Barret speaking from the CEF eSignature team. So indeed, now we'll maybe go into more details regarding DSS. But before we do so, we thought, before really going into the real code, as you will see in the live coding session, we thought it would be interesting to first do a quick recap of a set of topics that are related to digital signatures, and that you will see DSS handles in the coding session afterwards. So this section is more about doing a kind of an overview of the different concepts surrounding digital signatures. Next slide, please, Luis. Yes. So digital signatures, and we say digital signature, it's about both three: signature creation, signature augmentation, and validation. We will see in later slides what it means. When we talk about digital signatures, we talk about typically public key certificates, digital signature formats, maybe also qualified electronic signatures if we link it to the eIDAS regulation, but at least advanced electronic signatures that are typically supported through digital signatures, and the complexity of signature validation. So what we propose today is to cover these topics in a few slides. Of course, considering the limited time frame, we cannot go into details today. But as you will see, we refer to documentation and standards if you want more information. But at least we cover these topics so that if you have prior knowledge to it, then it will be a brief recap. If you don't have prior knowledge to it, then we would advise you to go to the documentation for further information. So let's start with the public key certificate. So when we talk about digital signature, we talk about indirectly about a pair of public key and a private key. The private key is used to sign, to actually encrypt a hash of the data to sign. And the public key, the private key, should remain secret, of course. And the public key should be known by as many people as possible so that the relying parties can verify that it's actually your signature. This is the basis of digital signature. This public key, to be really useful, you have to bind it to an identity. So you have to bind a key, a public key, and the identity of a person. This binding is done by a certificate, and the certificate is issued by what is called a certificate authority. And in the terminology of eIDAS, this certificate authority is actually a TSP, a trust service provider that will issue these certificates. And so as long as you can issue these certificates, this TSP can issue these certificates, then you know that this signature has been done by this person. This is one of the topics that we will cover in the next slide. Second topic, sorry, no, Luis, sorry, yeah, thank you. Second topic, digital signature formats. As we will see, there are different formats because when you create a signature, you don't only create the encryption of a hash, but you create different information. We will see which information. And so you have to encode this information in a certain format to ensure interoperability of the signature and to ensure that people on the receiving side will understand your signature. These are the standards. These are standards about these formats. And ETSI has created such standards. And then we will talk about levels. Levels, it's different information that you include in the signature or next to the signature to ensure certain benefits, to have certain benefits. For instance, robustness of the signature on the long term. This is typically an example. Third topic, qualified electronic signature. If your plan is to use DSS under eIDAS, and if your plan is to validate electronic signature and verify if they are qualified electronic signature or not, then this is exactly what DSS is doing. DSS, by default, when you take it out of the box, it's verifying whether a signature can be considered as a qualified electronic signature. Of course, this is a default behavior, and we will see, and Pierrick will show that in the live coding session, that you can unplug, if I may so, this behavior and handle any kind of digital signature you may like. As we will see, DSS is very modular, and so you can decide to include modules or not, and these validation of qualified electronic signature is just one module, if I may say it like that. When I talk about qualified electronic signature, so it's a legal concept from eIDAS, and under eIDAS, there are 3 levels of electronic signature. The basic one, the advanced one, typically supported through digital signature, and the qualified one, which is actually an advanced electronic signature, but based on a qualified certificate. It's a special certificate that is issued by a special type of TSP that is called QTSP, so a qualified level of TSP, meeting very strict requirements that are laid down in the regulation, in the eIDAS regulation, and protected with the private key, protected by a QSCD, a qualified signature creation device. And so these 3 elements in combination creates what is a qualified electronic signature. So this is why we are talking here about QES equals ADES plus QC plus QSCD, because you need these 3 conditions. And this is typically what DSS can create and DSS can validate. If you want to validate qualified electronic signature, you then will have to access to what are called trusted lists. Trusted lists are XML information, XML list provided by each member state of Europe. Each member state of Europe is required by the eIDAS regulation to publish one trusted list that contains these so-called QTSP. So they list the TSP that are qualified in their country, and DSS, when you want to validate a qualified electronic signature, has to access these trusted lists online to check this qualified status, whether they are qualified or not. Of course, again, you can use DSS for any other topic related to digital signature, and you can just unplug that behavior, but it's just to give you a first feel of the typical things that DSS is doing. And then I come to the latest topic, actually, that I already kind of covered in this explanation, is the signature validation. So whether you are validating an eIDAS or an advanced electronic signature or a qualified electronic signature, you are actually implementing a full process and a very complex one, as you will see in the later slides. And the purpose of DSS, as Luis explained, is to implement all that in full conformity with the standards, so that you don't have to take care with all the nitty-gritty details of these long processes and complex processes, and you can just reuse DSS as a black box and integrate in any business process you may find appropriate. Luis, can you? Yeah. Okay. So let's get back to public key certificate and public key infrastructure. Very briefly, again, time is limited, but typically, as you see in the bottom left corner of the screen, first usage of DSS is to create signature. So integrating DSS in a signature creation application. This signature creation application will have to access a private key, most probably protected by a signature creation device, maybe, but you will see in our demo that just for the sake of the demonstration, we are creating test private keys in software. This is completely possible, of course, with DSS as well. And to that private key, there is a related public key that is bound to an identity in what is called an entity certificate issued by a PKI hierarchy. So the TSP is the one, this root CA sub CA that you see above. This hierarchy is the one, the TSP, that will issue these certificates for you. And the whole private key, actually, the whole PKI purpose here is about distributing this key, this private key and public key, and making them usable. Making them usable so that this private key can be used securely to create signature, and the public key can be used on a wide scale to verify that actually you or me indeed were signing that document at that moment. So let's take a look on the receiving side, on the validation side. So bottom right of the screen, DSS can be used for validating application, meaning that signature validation application, meaning that you receive a signed document and you verify if the signature is valid or not. For that purpose, as we will see, we have to verify that the certificate is valid. I'm not entering into the details, but typically validity is about whether the certificate is expired or not, because the binding I was talking about has a limited duration for certain reasons, security reasons, and the certificate can be revoked. This is also one of the purpose of a PKI, is to inform everyone if, for instance, you lose your key or you get hacked, then you can tell the TSP, hey, my key was hacked, please inform everyone. And the way they do that in the framework of a PKI is to publish what is called a CRL, or to have an OCSP responder. A CRL, it's a certificate revocation list. It's just a list listing all the certificates that should not be considered as valid anymore. And OCSP, it's exactly the same, except that for, I would say, it's a different implementation in the sense that it's a query, it's a request and reply protocol where you ask about the validity of one certificate and you get an answer. OCSP stands for Online Certificate Status Protocol. So that's about it for the general behavior of the PKI and the way DSS can play a role here. I see a question in the chat. I don't do any assumption here about where the private key is located, and we will see that DSS can cope with a lot of different topologies. The private key can be local. For the sake of the demo, this is what we will do. But the private key can be located at the TSP because it is completely feasible under eIDAS. Next slide, please. So we were talking about digital signature formats. Indeed, signature exists in different formats. Formats are standardized for the purpose of being interoperable. Of course, as you understand the process that I presented, signature has to be created in a certain way so that people on the receiving side can understand your signature. And this is the job of ETSI, for instance. ETSI has standardized different formats. A signature at the end, it's not just a hash that is encrypted. It's way more than that, because you have to include other data, and we will see which kind of data necessary to understand the signature. And so you have to put that in certain format. You can do that in binary format, this is KDS. In XADS format, this is in XML format, this is XADS. In PDF format, this is PDS. ASIC is a container. It's a zip container. It's not a signature format on itself. It's actually a zip container in which you can put both documents and signature. So it's a kind of it's really an associated container in that sense, very flexible. And there is a new format that is still in draft that you may find maybe interesting for web communication is JDAS. So it's based on JSON syntax, JSON or base64 URL encoded JSON. I'm not entering into the details, but mainly JSON based. Signature format, you will also need to decide whether you want to create your signature as enveloping, detached, or enveloped. Let me explain a bit. Here, the formats are about the format of the signature, not necessarily the format of the data you will sign. So you can completely sign a PDF with XML. Certain combinations are impossible, of course, but here I'm talking about the way the signature is formulated in bytes. Not the data that you will sign. When I'm talking about the enveloping, detached, I'm talking about a packaging, because there are different possibilities. You can decide that the signature contains the data to be signed, the PDF, for instance, the image, anything. You can decide that it's the other way around. It's the document that contains the signature, or you can consider that the signature is completely detached. It's a separate file from the data you are signing. So these are the different both packaging and formats. These are defined in ETSI standards that are listed here. So for further details, I would encourage you to go to these standards that are publicly available on the internet. Luis, can you? Yes. So we were talking about formats. Now we can talk about classes. For each of these formats, and actually whatever the format, there are classes that have been defined by ETSI to cover different needs and to reach certain goals in terms of benefits you want to have with the signature. Let me explain. The standard, the basic format is the basic signature. It's properly called. What you need for having a basic signature, you just need the document or a representation of the document. You need what are called sign attributes, meaning that these attributes will be the scope of the signature will span on the document and these attributes, so that you can make sure that these documents were not modified after the signature. They are kind of carved in stone together with the content of the document into the signature. So no one can modify them without having an integrity issue when validating. What are these kind of attributes? Typically the signing certificate, of course. It's very important to know who has signed and to have that information in terms of identity and not just in terms of public key. A claim time. You can put a time, it will be a claim time. You can put a location, etc., etc. There are different fields that can be included in the scope of the signature. You have the signature value itself. That's the core functionality of that. It's a hash that is encrypted after all. And then you can add unsigned attribute. Unsigned meaning that you can see that as metadata because it's not in the signature. It's unsigned. It's outside of the scope, but it's still very, very useful. For instance, one of the unsigned attributes that is typically useful is what is in the signature with time, where you will put a time assertion, a timestamp, for instance, to have a proof of existence of the signature at a certain moment in time, or at least before a certain moment in time. Why doing so? To protect your signature against the expiration or the revocation of the certificate. If you can prove that the signature has been created before the expiration, before the revocation of your certificate, then you can prove it was validly signed. Let's go on with the other classes. Second level is long-term validation material. I'm not only putting, as you can see, every time the one class is building on top of the previous class. In terms of unsigned attribute, what I can add after timestamp is revocation data. This level, long-term validation material, is about making sure that you have included in the signature all these CRLs and OCSPs, responses we have seen in the previous slide, so that just in case they are not available anymore at the moment you will have to validate the signature, you put them in the signature to be sure that you will find them back, if I may say it like that. So it's really, the benefit here is about really protecting the signature against the unavailability of the information. Next slide. And then there is the latest, I would say the most complex level, which is the long-term availability and integrity of validation material. You not only include the validation material, but you also include a timestamp on it to protect your validation material and provide a proof of existence of this validation material. And actually, if you do it on a regular basis, you can see that this level, this is what is shown at the bottom, this level is actually more than one level because it's a kind of a nested level that you can reapply on itself every year, for instance, in a kind of a pattern that is called Russian doll, for instance, if you see what I mean. It's really nested levels. If you do it on a regular basis, like every year, you will protect your latest timestamp with a new layer of timestamp, and you will, for instance, protect about cryptographic obsolescence. You know that an algorithm, a crypto algorithm, is strong just because computers are, between brackets, weak. But suppose the computation power increases in the next year, and this is what happens typically, then it may be considered in later times that actually your crypto algorithms are becoming weak and someone could fake a signature as if it was signed in the past. And so to prevent that, it is advisable to preserve your signature in such a way. There are different ways, but this is one of the standard ways. To preserve your signature on the long term if you want to keep your signature for, I don't know, 10 years, 20 years, maybe 30 years. Next slide, please. So these classes were actually abstract concepts from ETSI, and then ETSI is translating this, implementing this in what are called levels. It's exactly the same. It's just that now we are talking really about XADES, KDES, PDES format. And so we will talk about, for instance, XADES-B-B to talk about a XADES baseline profile at B level. XADES-B-T will mean XADES format baseline profile with a timestamp, T level, etc., etc. So as you can see, the B level is just the signature with the signed attributes, and of course the original data. Timestamp is putting a timestamp on it, etc., etc. Next slide, please. Third topic to be covered before we go really about talking about DSS itself, it's validation. So you have created a signature, or you have received a signature from another party, and you want to validate it. As we can present here, there are a lot of checks to be done to really verify that the signature can be, between brackets, trusted or not. And these are, for instance, on the left column, for a digital signature to represent an advanced electronic signature. You have checks like, of course, the cryptographic binding between the document and the signature value, but also cryptographic constraint. You may consider that, for instance, certain algorithms are acceptable and some are not. You may consider that in 2020, this algorithm cannot be accepted anymore because it's too weak, and because of the current computing power, it's too easy to have a collision and create a fake signature. You have to verify that the certificate is expired or not, is revoked or not. You have also to verify that the issuer of the certificate can be trusted or not, and it may be a personal decision. So you have a lot of these checks. You have also, of course, to process these levels that we presented at the T level, LT level, LTA, and you see that it can get very, very complex because it can be nested in several layers. And all of that is actually standardized in a procedure from ETSI that is called ETSI 319102-1 at the bottom of your screen, bottom left. And again, freely available on the internet, so please have a look to it. You will see that it's a full procedure for both creation and validation. The complex part is indeed the validation part, and it explains all the steps that have to be performed to be in line with this standardized procedure, and this standardized procedure translates the good practice to be done to validate a digital signature. If you want to validate a qualified electronic signature in the sense of eIDAS, so you don't only have to validate the digital aspect of the signature, the advanced level, if I may use the legal term, you also have to verify the qualified status of the certificate and the qualified status, the presence of a QSCD. So you can see that as a first call to the eIDAS part, and then additional things to be verified in terms of qualification, where you will need to access the so-called trusted list we talked about in the past. And for these, for this part of the procedure, there are again ETSI standards that are existing, and these are first the rules for such a determination. This is the 119.172-4 that explains how to augment, if I may say it like that, or customize the 319.102-1 from the eIDAS part for the qualified situation. This one, as you will see, is relying on another standard, just focusing on how to interpret the content of a trusted list. This is the 119.615, a very interesting one on how to process and interpret the content for the purpose of such algorithms. And if you combine all these, then you can set up an automated conclusion on a qualified status of a qualified electronic signature. And this is one of the things that DSS is doing, is being in line with all these standards and automating a conclusion. You give DSS a signature, a signed document, for instance, and it gives you a report explaining the conclusion. Next slide, please. Okay, now we have covered the topics. Let's focus on DSS itself. So DSS, as we said, it's about creating, augmenting, going from a T to an LT to an LTA level, and validating, receiving a signature and verifying it, as we explained. DSS is about all that. So managing all these levels, managing all these procedures, both on the creation and the validation side. A few characteristic words to mention, because some of them will be covered in the live coding session. First, on the creation side, there are actually 3 stateless methods that can be that are separated. And actually, we have separated them for a clear purpose that is to cope with different topologies. You can separate the preparation of the data to be signed, so the document, the data to be signed, and the signed properties, as we saw. You can separate that from the real computation of the signature, so really the hashing and the encryption of the information, and you can separate that from the building of the format, the construction of the format based on the prior steps, and you can deploy these three methods in different topologies. You can deploy one part locally. You can suppose, for instance, your smart card is local, so you want to sign locally. So the second step will be local, but you can put the rest on a server if you want, because you want the construction of the signature to be done on the server and the access to the OCSP and CRL and all that from the server. So you can really choose the configuration that is best suited to your project. Second thing that we will illustrate in the live coding sessions is the fact that with a validation comes a validation policy, meaning that a set of rules to decide whether a signature is acceptable or not. You can configure that behavior. The default policy, as we said, is based on 119172-4, so the one for concluding on qualified electronic signature and testing the qualified certificate status and these kind of things. But this default DSS policy can be relaxed in some aspects for some constraints or strengthened, as you will see, as Pierrick will show you. You may decide also in terms of validation policy to rely on other trust anchors, so anchors of trust, others than the one that are present in the EU trusted list. Again, the default behavior of DSS is to use these ones. But if your project, for some reason, is not relying on the trusted list, but is relying on a maybe private PKI or another infrastructure, then you can completely configure DSS to access this information as trust anchors in replacement of these default source. You can use DSS as a web service because we have from time to time the question on the support. DSS is written in Java, but if your project is not in Java, you can still use DSS because you can still deploy DSS as a kind of a black box with an interface as a web service, so that you can continue developing on your language of choice and contact DSS through that interface to create or validate signatures. Of course, in the bundle, you will see there are default interfaces, and you can live with them, but you can also modify them or create new interfaces. As a library, you can use it, and mostly, as you will see, in a Maven project, it's very, very easy to plug DSS and start using it. Next slide, please, Luis. Okay, how to get started in one slide, very simple. You go to that page on the right of your screen. You download a bundle of DSS. In the bundle, actually, it's not just DSS as a library because DSS is library and nothing else. But just for the sake of demonstration, we have created a demo web app that uses the DSS library on a web page with all features of DSS, as many features as DSS exposed as possible, so that you can test easily and quickly DSS. And so there is a startup.bat to start this little web application server. And then there is a shortcut to access this main page. And so you can really test the functionalities just 2 clicks. Of course, can be even more simple because you can access this demo, but on the CEF portal. Here is the link on your screen. And so click there and you will see that you can easily test the creation and validation of signature with no problem. As you can see also, the style sheet of this demo is basic on the left, and you can customize it as we do, for instance, for CEF. Here, you can see that we have customized it to the look and feel of the European Commission. This demo is just a demo again, but you may decide to take that as a kind of a start, or at least inspiration to create your own web application based on DSS, which is again just a library inside this bundle. Next slide, please. So a few useful links. I will go quickly through them because I want to leave more time to Pierrick for the live coding sessions. The cookbook is maybe the first document to read because it illustrates, I mean, for a developer, it illustrates a wide range of typical and maybe difficult use cases. And so this is certainly one resource to have a look to. You have a Jira ticketing system where you can drop us suggestions, bugs, new features, questions also, so don't hesitate to use it. If you want to integrate DSS in your Maven project, no problem. Here is the snippet of code, but Pierrick will illustrate that in a few minutes. If you want to access the source code directly, this is the GitHub. And just as a reminder, there is a general CEF eSig FAQ page where different questions on eSignature are answered, and among them, DSS questions. Next slide. Thank you. So I was saying that DSS is very modular, and here is an illustration. You have really a full set of modules, and Pierrick will illustrate that as well. This modularity means that you really can cherry pick the modules you want to include into your project and not have to include the whole bunch just because it's monolithic. So for instance, all spec modules, they are the modules containing XML schema and Java binding to this XML schema related, for instance, to trusted list, XADES format, all these things that are in XML. You have the bindings there. Suppose you are only using XADES signature in your project. You can just include the module of XADES, but get rid of PADES and other format. Suppose you will use a signature that are qualified electronic signature, and so you will need to access trusted list, then you have to include the corresponding module. If you don't, of course, you can just get rid of the module. If you plan to access online resources, such as timestamps, OCSP, CRL, you include the module DSS service. If you don't, for instance, if you only create signature, but you don't validate signature, maybe there is no need. There is no need to include that module, and you can get rid of it. You can even choose between different implementations. For instance, for PADES, there are two libraries for PDF, Open PDF and PDF Box. You can choose the one you find more appropriate. Same for some utils packages like Apache Coms. You can select the Google Guava instead if you think it's more appropriate in your project. Next slide. Okay, that's the last slide of the presentation before going into the live coding session. Just a last word on the validation side. So on the validation side, it's only one method, very simple, validate document. Again, it's performed against a validation policy that you can customize. By default, there is one that validates qualified electronic signature and advanced electronic signature based on qualified certificate, basing this decision on the content of trusted list, so trusted list based. But you can configure it the way you want. For instance, you can kick out some cryptographic algorithm if you think this is not appropriate. You can decide if OCSP or CRL are preferred or not accepted, or anything you find appropriate in this kind of configuration. The result of the validation is a report about the outcome. Actually, 4 reports. The main report for a technical person is the detail report, the second one listed here. This detail report contains all steps of the ETSI standards that have been provided, really explicitly, all of them. The simple report is a summary of the conclusion and information of the detailed report. The diagnostic data are all information that have been gathered by DSS to conclude. So it can be useful maybe to, I don't know, reuse them, store them, archive them, but it's provided as also a result. And there is a last one that you may find interesting. It's a standardized validation report, because ETSI has also standardized this report under a standard that is called 119102-2. So -1 is the procedure, -2 is the validation report as a result, and ETSI and DSS is aligned with it. So that's it. Next slide, please, Luis. I will now give the floor to Pierrick for this live coding session. We will illustrate these steps. So, of course, how to first set up the workspace, sorry, but then play around with a signature, creating one, validating it, extending a signature, so augmenting the signature to an upper level, and modifying the default DSS validation policy as we discussed. So I will now let the floor to Pierrick. Thank you very much.
Okay, now, Pierrick, are you there? We cannot hear you, Pierrick. May be muted.
Good afternoon. I will share my screen.
Sorry, Pierrick, but we cannot see your screen yet.
I have no button to share my screen, so I'm not able to.
Luis, I think you need to put in presenter.
Yeah, let's see. Okay. Let's see if you're able to do it now. Can you share the screen now, Pierrick?
Yeah, I'd like to share my complete screen. Do you see?
Yeah, we can see it now.
Okay, so good afternoon, everyone. My name is Pengan Brook, and I'm the lead developer on the DSS project. During this live coding session, I will illustrate how to integrate DSS in a Maven project and how to configure it to do a eIDAS signature, to extend it, and then to validate it. First of all is the GitHub website. So here you can find all the source code of the DSS project and all its unit tests and documentation. All the documentation is in the DSS cookbook here, and you have the different module as explained by Olivier earlier. In the README session, you also can find explanation about the build, explanation about the Maven repository. So all JAR are hosted on the Maven repository of the European Commission, on the Safe Digital Maven repository. You also have some additional profile to do compilation and so on. You have a link to go to the documentation. Example to do web service call with SOAP UIs or SOAP web services, or Postman for the REST service. You have also a complete Java doc and link to go to the demonstration website. Now I will show you how to configure a project in Eclipse. Here I created a small Java Maven project for the webinar. So first of all is the Maven configuration. So here my pom.xml file. So here I added a needed repository that will allow me to download automatically the different dependency. For this demo, I will do all my illustration with DSS, so the advanced electronic signature based on XML. I chose this one because that easiest way to illustrate how is the signature in the result. So to do the demonstration, I need DSS eIDAS, so that contain all the eIDAS implementation. So this module will allow me to create eIDAS signature, extend them, and validate them. To do my electronic signature, I will also need DSS token. So this module contains several implementations to interact with several tokens. So you have PKCS 12, 11, MSKP, and GKS implementation in this module. Additionally, DSS also use several utilities methods. So you have two different modules which do exactly the same things. So the first one is based on Apache Commons libraries, so Common IO, Common Link, Common Collection, and so on. And the other one is based on Google Guava. And the last dependency is only for login, so not interesting for now. The first demonstration will be to create a eIDAS signature. So for this purpose, I will sign the logo of the webinar. I will create a eIDAS enveloping signature, which will embed the picture in a base64 encoded format. I will firstly open create my document. The DSS document is an interface with several implementations. This one is based on a file, Java IO files. You also have in-memory document, which is based on a byte array on input stream. For this demo, I will use test PKI. So I will show you this one. So here you have several PKI. So I created some key store with certificate, private key, with valid certificate, revoke certificate, expired certificate, and so on. So in this demonstration, I will use the good CDSA user. So that certificate based on a CDSA key pair. So in my signature, I will get the signing certificate good CDSA user and get a chain until the root CA, which is my trust anchor. So I downloaded my key store here, so it's a PKCS 12 key store. With my DSS token, I can open it with my implementation of the signature token. Yeah. So it takes one file and the password to be used. In the demo, in the PK factory, all key stores are available to download here, and all of them share the same password for to ease the usage. So I configured my token. Now I need to retrieve the key information about my user. Okay. To do a XADE signature, I will need an instance of the XADE service. So this service is very similar to other implementation with CADES, PADES, ASIC, and in the future JADES. So this service offer you the different needed methods to create a signature or to extend them. So I create a new instance of the service and I can find my stateless method, so the get data to be signed and the sign document method. You also have different methods to help you to do the content timestamp, to do a timestamp signature for a PDF file, for example. Now I will call my get data to be signed with my document, and I need to provide some parameters. You have here the specific class for XADES. To do an electronic signature, you need to provide the signing certificate. Here, key get certificate. You also can provide the complete certificate chain. I recommend to provide it. That help other implementer to validate your signature. So I'm signing a picture. So I will use the encoding packaging. Packaging. Okay. And I'd like to do a basic signature. I'm configuring the signature level. Here you can find the different levels. So the basic one, the level with a timestamp, the level with the revocation data, and the level with the archive timestamp. Currently, we use the basic one. Next, I can configure my encryption algorithm. So my key pair is based on the CDSA, and I'd like to do my signature with a strong algorithm, digest algorithm. So I will use, for example, SHA 512. Okay. So here I have all my parameters to be able to create a XADES developing signature based on the CDSA. So I call my method get data to be signed. So this method returns a binary ready to be signed with your token. We call this variable to be signed because it's not a digest. I will show you two different ways to operate the signature. The first one with the sign method, where I can provide the to be signed data. My parameter with the digest algorithm and my case. Here I retrieve my signature value. In this operation, the signature is a digest and an encryption in one step. And now I can call my third method, the signed document with the original file, my parameters, and the signature value. So these three methods can be called independently on different machines, different computers. They are completely stateless, so DSS doesn't store any information in the cache or something like this. So it's very important to provide all parameters and equal parameter to these two methods. When I call the signed document method, DSS will create the signed document, so incorporate the signature value inside the document. And I can store it in the target folder, for example. I have my signed files here. I will open in the browser. I can see my signature, the signed information, the signature value, the certification, the different eIDAS properties, and my picture in base64 here. I will do quickly a validation with DSS. So this demonstration is configured to trust the different European trusted list and my test PKI here. Now I can see I get my ZSB with a total pass result and my chain of certificate here. And you can see the 4 different reports. So the first one, the simple report, the detailed report, which explain all the different steps that DSS follow to get the total pass conclusion. The genetic tree, which contain all used data, so signature, certificate, revocation data, and timestamp. And the last one is the ETSI validation report. So the ETSI standardized validation report. I said that this data was not a digest. I will store to show you what is it exactly. with the eIDAS format, that's an XML which contains the standard information, like, and the different digest. If I want to do I can do firstly the digest and then a raw signature on the token. Now in this line, I compute firstly the digest value, and here I provide my case. So here the signature, the computed digest and all signature. You can see here none with a CDSA. So the token didn't operate any digest. If I do validation, get a total cost signature. Now I'd like to extend this signature. So for that, I will use my standard document. I will use an instance of my service. So the certificate verifier, we will see in the validation part what is its usage. But for this demo, I only need to call the extend method with my document and the different set of parameters. In the parameter, I need to specify the expected final level, signature level. I will do a eIDAS with a timestamp. Now, to do a timestamp, I need one more dependency in my form.xml. It's the DSS service. The DSS service dependency contains different classes that help you to interact with the online world. So OCSP server, CRL server, timestamping server, and so on. It also contains implementation with cache, so database cache, file cache, and so on. So I added my DSS service dependency, and now I can configure my service with a TSP source. So TSP source, it's a class which will request my timestamping server. So I will use test timestamping server. So this one, for example. So here you have several timestamp, fake timestamp authority. I'd like to configure my demo with this one. So a timestamp server should be interacted, should be called with a special data loader, timestamp data loader. So this one, for example. So this timestamp data loader has the specific content type when you interact with the timestamp server. So I have my document to be timestamped. I have my ZS service with the TSP source configured. I will call the extend document method with my parameter and the expected ZS B90 level as parameter. And I will store the result in my target folder. Okay. So I can see in the console that I am extended the signed XML file and the online TSP source called the TSP, the timestamp server, and get a successful response. I will validate with the demo. So I can see ZS B90 and additional validation step for the signature timestamp here. If I like, I want to see the detail of each validation, I can click on details, and here I can find back the different validation step from the ETSI 319102 part 1. The last part of the demonstration will be the validation. So now I will show you how to configure DSS to do a complete validation. DSS has this main class of the signed document validator, which take one document in parameter. And depending of your project configuration, DSS will automatically recognize the kind of document that you are validating and instantiate the correct validator after the recognition. So to do the validation, I will need to configure a complete certificate verifier. In the certificate verifier, you have several things to configure. The first one is the data loader. The data loader. So this data loader explain to DSS how to which data loader it needs to use to collect certificate from authority and information URI, so the IA information from the certificate. This one. I need to explain to DSS how to request CR, so source. Now this implementation collect on online mode without any cache. You have several other implementation in the source or cache in a database or on a file system. An alternative way to retrieve revocation data is with the OCSP source. So once again, I will use the online implementation. And the last thing, the most important thing is the trust and core. I need to configure the different trusted certificate source. So I can configure one or more trusted source. So for example, I can configure the local and trusted list content and my private PKI on my factory. I downloaded my root CA here. Here I have everything configured. My validator is configured with a certificate identifier and several needed information. So the data loader to retrieve missing certificate from IA in the certificate. The CRL source allow me to download CRL. The OCSP source, which will allow you to request OCSP response, and my trusted certificate source with my trust and core. So to validate, I need to call validate document, and the result will be a report object. So this report contains the four different reports. So the simple report, the detailed report, the denoted data, and the ETSI validation report. I will run the print method to see, to show you. So the print method is only for debug purpose. So it only simply print the different report in the console. Run again to get my complete console. So I can see the genetic data, so that contain all needed information to do my validation. And then I get the detailed report, so it contains all the follow-up steps to conclude my validation. Then I have the simple report, which contains the summary of my validation. So here I can find my signature level, I can find the certificate chain, I can find the indication and several information. And then I have the ETSI validation report, which is the standardized way by ETSI. Now I'd like to show you how to customize the validation process. So in this demonstration, we use the default validation policy, and you can see that you have one error here because this certificate is not related to a trusted list. That's only a test PKI, so I'd like to skip this step in my validation. So the default policy is available in the DSS policy JACP module. In the main resources, you have policy. This one is the default policy based on the 119.172 part 4. And you have also one specific validation policy for trusted list. I can open both. Now this one contains all execute step by default in DSS. All steps can be configured differently. So for example, here I can skip this validation, or I can change the level of the validation. So you have different levels, or you completely remove it. So the check is completely skipped, or you report an information. So the validation process continue and only inform you about the finding. Or you configure with a warn, so you will get a warning in the validation report. Or you can configure with fail, so fail will interrupt the validation process and return the last fail message. Here is the complete validation policy for the 119.172 part 4 with the ETSI recommendation about algorithm creation, for example, here. For all algorithms, you have a reference date and the reference standard. And at the bottom, you have a eIDAS specific constraint. So this part will process the qualification part of the signature. So with the trusted list, we will check if the signing certificate is related to a qualified trust service provider, and then compute the 119.1.615 algorithm. So this policy is the default one in DSS. And alternatively, I can show you one lighter policy, which is only used for trusted list. So trusted list, there is line B signature. So I only accept this kind of format, and I have some more constraint, but I don't need to check the qualification and so on. So I have a limited constraint files. So now I will download this one and adapt to my my use case. Okay. I will change my policy, so custom policy. Another is not connected to qualify, so I will change another. And I want to skip the last step. So I comment it. And in the validate document, I can provide my custom policy. File. And I will only display a simple report. And you can see that the warning I had before disappeared. And you can see here the used policy or my custom policy. Now, issue an additional question. I propose to be back then to Luis. So thank you for your attention.
Yeah, great. Thanks, Fredrik. Okay, so what we're going to do now, it's we're going to have a Q&A session in which you will be able to make your questions openly and ask about anything from the content of the webinar, and the technical team will come across your questions. So yes, if you allow me 1 second to share some content. Yeah, so Fredrik, sorry, you need to make me the presenter so I can share the content. You know how to do it? Yeah, great. All right, thanks. So, okay, so here's the tool that we're going to use for the Q&A session. So please, if you're so kind to go to www.menti.com and use this code, you will be able to make your questions and they will start appearing on the screen. And as they appear on the screen, the technical team will solve them. Okay, so in the meantime, Olivier is going to answer the questions that were made in the chat.
Yes. Olivier Barret speaking. So maybe yes, in the meantime, when you are introducing the question in Menti, I can already go through the questions we received in the chat. The first one was about an option where the private key is generated locally. I hope that in the meantime it was clarified with the slides and the live coding session. The support of DSS of HSMs. So what actually indeed we didn't say is that DSS supports different interfaces to connect to the key, PKCS 11, PKCS 12, MSKP, etc. So there are a list of these standards that are supported that are listed actually also in the cookbook. So as long as the HSM is supporting one of these standards, no problem. And if the HSM doesn't support that standard, there is still a possibility to customize, of course, the access to the private key. Third question, DSS is currently recognizing PKCS 7B level with QC, so with a qualified certificate and a QSCD as QES. Please comment why. Yeah, maybe it deserves a bit of explanation. So legally speaking, a qualified electronic signature in eIDAS requirements is an advanced electronic signature with a qualified certificate and a QSCD. There is no requirement of support of a standard, obligation of any standard. And so as PKCS7 is just one standard among others, although not, I would say, a latest ETSI standards, we thought that it would be interesting because typically this is what you receive when you create a signature through Adobe Reader. At least in a few years ago, it was that format that was created if you kept the default configuration in Adobe. And so for the sake of supporting as many formats of signature as possible, in addition to the standardized from ETSI, we supported that one as well because it was not, I would say, an extensive effort to support this one. But again, we should split the discussion between what is a technical format and what are the legal requirements in terms of qualified electronic signature. And in terms of qualified electronic signature, legally speaking, if you have an advanced electronic signature with a qualified certificate and with a QSCD, you have a qualified electronic signature in legal terms. I hope this answers the question. Does DSS has been security evaluated? So we test DSS frequently internally at the Commission, but also through universities, for instance, against shadow attacks, wrapping attacks, etc. If you are talking about a security evaluation in the sense of a common criteria, for instance, evaluation, then no, we have not performed such a security evaluation so far. In terms of ETSI report, a question, is the validation report, the XML code similar to the third tab? No, the diagnostic data is really the raw data that has been collected by DSS to then use it as information to then conclude about the qualified status, etc., etc. And so the validation report is really something else, and I encourage you to read the corresponding ETSI standards. I think I'm about, I'm done with the question from the chat. Xades LT, we had no time to show it, but I guess you have the point with what we have shown. And regarding the web app demo, to my knowledge, no, it's completely a bundle. I would say an offline bundle that you download on your own, and there is no information that is transmitted to the Commission. Let's then get back to Menti now. Do you have any demos of JSON signature? I will let maybe Pierrick reply on this one. Pierrick?
Yeah. So we have a pre-version installed on our Novena server, but that will be the first release candidate will be released next week. I can share the link on the chat maybe. So in the chat, yeah. So if you go on this link, you can see the different options. So this implementation is based on the draft standard. So the draft standard 119.182 part 1, version 0.0.5. So we still have some small adaptation to do before the release candidate of the next week.
Yes, so this is very really a very early release. The real release candidate will come in a week. Thank you, Pierrick. How the connection is made to HSM in the backend? Maybe this is a very advanced topic. I don't know if Pierrick can answer it shortly, or if we can maybe leave it for support question later on. Pierrick, what do you think?
So for this question, you need the DSS token module. So in this module, you have several implementations. So the main one is PKCS 11. So you need a driver. If you need to interact directly with the HSM and the storage keys, if you want to interact with the QSCD, which expose the certificate and private key with an API, that will require some more development on your side. For this question, the qualified timestamp requirement. So the qualified timestamp validation is specified in one standard. So the standard clearly defines what is a qualified timestamp and what is not. So this algorithm is cannot be changed, but the validation can be skipped with the eIDAS constraint, like I did in the live coding session.
This one is maybe to the Commission to answer because it's about funding research. I don't know if Tolis is in the loop.
I may partly reply.
Yes, please.
With ASIC, we already support open documents or LibreOffice documents. So if you do signature with LibreOffice, DSS is able to validate them, and we are also able to extend this signature. So for PDF, we support Adobe Signature, so based on PKCS 7 or based on PADES format. After, I don't know what was expected additional things.
Yeah, I understand that maybe the question was related to testing testing these tools and making and checking their compliance against the standards. But I think this is most probably outside of the scope of the CEF e-signature building block.
We
I can confirm this one. No, I can confirm with what Olivier Barrette just said that it's out of our scope, actually. Of course, we collaborate with a lot of representatives from the private market. Adobe is one of them. And we are doing our best in order to remind them, let's say, about the standards that we have here in Europe and the legal framework that we have here in Europe in order to be, let's say, compliant and conformant to the latest ones.
So for this question, from our knowledge, DSS is fully multi-threaded. So it can be used in a multi-threaded environment. We did some intensive tests with 90 build and multi-threaded validation. Normally, you should not have any problem with this kind of configuration.
Very interesting question. I think I will leave it to Tolis as well, maybe.
This is a tricky question. What I can say is that we do have already started the collaboration with third countries outside European Union or extended economic area in order to reach a mutual recognition on the qualified electronic signatures landscape. And yes, we do have solid plans, and it's something that is ongoing, but unfortunately, I cannot share more information for the time being. But our proposal or intention is to encourage third parties to reuse DSS because sooner or later we're going to have a uniform approach across the globe on this landscape.
For performance, it's quite difficult to evaluate between each version the different improvement. We have a signature pool which contain many signatures, and we do limitation on the validation process. So that's the only way to monitor currently. Between PDF box and OpenPDF implementation, I wouldn't consider the performance here, but I would consider the different features or implemented feature inside the implementation. So for example, the visual signature in PDF box is much more advanced and offer much more different configuration. For example, the embed text can be selected in Adobe with PDF box. That's not the case with OpenPDF. And in the common release, the 5.8, the effort about the shadow attack are much more advanced in PDF box. OpenPDF is an open source library, but offer less possibilities than PDF box. I don't see any error. Where do you see this?
Yeah, sorry, Perix, to interrupt. Maybe this is because they are relating the fact of using DSS with the trusted lists, basically. So the fact that you're using DSS is independent from the trusted lists. So DSS is something you build, let's say, to build a solution, okay, that it makes it compliant with the eIDAS, but it's
one possible issue is the SSL certificates. So by default, DSS use the Java key store and use it to download a trusted list. So if you use a deprecated JVM, that might happen, and you will get SSL error in the trusted list summary.
Yes, if I may step in, indeed, a JVM is shipped with a certain configuration of certificates to be trusted, the trust store, and it varies from one JVM to the other. So it can happen that this certificate has been issued by a C that is for some reason not part of the Java, the Oracle Sun trust program, and so that might explain. But if I'm not mistaken, DSS is still validating using the trusted list. Sorry.
For this question, in the DSS core, we provide some generic web service interface, so with SOAP and with REST. So that's only generic method, so we don't provide advanced configuration here. That could be used in production, but with an advanced configuration on your side. I mean, you need to configure which are your trust anchor, or to collect the revocation data, and so on. You have example in the demonstration project, but I won't. The purpose of the demonstration is not to be used like this in production.
Yeah, there are many projects that are using DSS as far as we know, but still, I mean, we cannot commit saying please use it in production as it is. It's a demonstration at first.
For this question, the PADE signature is enveloped. So the PDF format is a quite special format where all addition or all modification are incremental. So if you want to add one more signature to an existing signed document, that will add a new layer at the bottom of the document with a new signature. And when you sign a document, you always sign the previous version, the complete previous version, with some exception, like in with the shadow attack and some other very specific case. In the simple report, I wanted to be a clear distinction between the ETSI conclusion, so the validation process of ETSI, of the standard 119.102 part 1. So this standard explains the whole validation process to do the validation. This standard is completely independent of the European concept like eIDAS and qualified electronic signature and so on. So that's why we split it the validation conclusion in several parts. So you have indications of medication for the signature validation. You have a qualification, so that the result of the qualification determination algorithm. So the conclusion of the 102 part 1 and the conclusion of the 119.615 algorithm. And the signature level is one additional information to help you to conclude the validation. DSS accept both encoding, so UTF-8 encoding and UTF-8 with BOM. If you want to discard BOM-based files, that means you need additional additional check before providing the file to DSS.
Currently, DSS is configured indeed to process the trusted list of EU. So if you want to use it outside of EU, you have, of course, to take account of the national or regional scheme. That's the case for Switzerland. And we cannot talk, I mean, in the name of UK, but that maybe will be the case for UK after Brexit. Of course, depending on how far these countries align with the standards that are used in EU, that may be easy or not. We cannot say much more than that. For what Switzerland is concerned, to my knowledge, they use ETSI standards. So most probably, you can use DSS as a good basis, maybe with some tweaks here and there to reach the conclusions you need. Yes, I think it is the case, Luis. I don't know if you can say a word on that.
Yeah, definitely. The presentation is being recorded, and it will afterwards be uploaded to YouTube, so it will make it public. So in case any of you wants to come back to the live coding session, go step by step, or check the content that we provided you with, you will have the chance to do so.
Again, we cannot commit on what can be or when cannot be used in production in a qualified service. But to my personal knowledge, some QTSP in Europe are using DSS as the basis of their qualified validation trust service. Indeed, but I would say it's up to every legal entity to decide whether it is fit for purpose or not. At the end, DSS library, it's a reference implementation against standards, but it's an open source software with no commitment, of course, and liabilities regarding the usage and in such service.
Okay, so until here with the questions, we have already overextended a bit the meeting. Thank you very much to all the participants for coming and checking with us. We will send you back the presentation of the meeting, and as I was saying before, we will upload the content and publish it on the CEF digital webpage. So we'll come back to you with the link to check this also in order to make it easier for you. So thank you everyone, and we'll see you in the next webinar.
Thank you very much. Thank you.
Thank you very much, everybody. Have a good evening.